Good morning to all. This is Muthu Srinivasan, Assistant Professor, Department of Computer Applications, Sri Kadishwari College. Today we are going to discuss about the inter-process communication in the subject operating system. IPC is one of the important one. The executing process is always in the concurrent mode. One process is always intervened with the another process. So to channelize this kind of process, we must use the inter-process communication. The process itself is of two types: dependent process and independent process. The dependent process never interfere with one another. Suppose P1 and P2 are the process, they are, if it is assumed as an independent process, that process will not interfere. P1 never interfere with P2 or P2 never interfere with P1. That type of processes are called independent process. And some process may be the cooperating process. Cooperating process means one process will stick its noses to the work of the another process. For example, P2 can interfere with P1 and P1 can interfere with the P2, or it is shown as it affects, one process affects the another process, that is in the cooperating mode. In that scenario, we must use the inter-process communication. That concept is called IPC. That IPC can be done in two ways. It is in the shared memory as well as in the message passing. The shared memory means, look at the picture, picture B. We have two processes, process A and process B. Both process A and process B is sharing the same memory location, shared memory. It acts as a repository where which process A can send the message to the shared memory and process B can receive the content from the shared memory. Or else simply we can say process A writes the content to the shared memory and the process B reads the content from the shared memory, or vice versa. Vice versa in the sense B can do the similar task as like as A. So this is the shared memory concept. The region of the memory in the cooperating process is established first of all. That is the shared memory. The cooperating process accessing that shared memory. Another model is called message passing. Message passing, the two entities are different. It never share the same location. Suppose the entity A want to send the message to entity B, means both are in the different location, not in the shared location. The message passing is used in the internet nowadays. The client is sending message to the server and server is responding to the input from the client. These kind of tasks are called message passing. One example is given: you send a message, your friend receives the message, and a communication happens without sharing the same space. You and your friend may be in the different location, not in the same location like the shared memory. The shared memory content is mutually shared between both A and B. But here in the context of message passing, both are at the different locations. They are using the message queues and buffers to transfer the message. In the case of message passing, process A is sending the message to the message queue. The message queue just queued up the messages. Later it sends the message to the process B. Like the same, process B can send the message to process A via the message queue. The shared memory model is like your notebook. A person write a note, content in the given note, and the same note is given to person B. The person B is sharing that note, and he or she can read the content. Or simply we can say, we can write, A can write the number 10 to the shared memory location. In the same case, B can receive the same number 10. Sending and receiving, in message passing, sending and receiving is done using the system called to send and receive. We have to synchronize the message passing. The main issue is to synchronize. A sending message to B, but A should be confident that B can receive the message, and B must send the acknowledgement to the sender. Then only the next communication will happen. In the distributed environment, yes, in the message passing system, both A and B are in the distributed location. Distributed location in the sense we know about the internet. Everything is in the distance. Or one particular machine cannot know about the identity of the remaining another machines, the receiver. The communication link is very important here. That link may be physical or logical. Physical may be in the computer network, you know about the physical connection, copper cable, coaxial cable. These kind of connections are done between the two entities. The logical connections are nothing but the mails the message queues and these kind of things. Both synchronous and asynchronous communication can happen here. Synchronous communication in the sense the sender should wait and he must prove that receiver is receiving, then only it sends the next message. Thank you.